This is the video for our coffee cup calorimetry lab. So the supplies for this lab is you will need 2 coffee cups, 1 lid, a magnetic stir bar, the stir bar removal stick, and then we are going to be using the Labquest and a temperature probe. So the temperature probe just plugs into the side here, and it's called channel 1, and the on button is on the top of it, just a little red button. So you just turn it on, it can tell what the probe is, and then you're all set to go. So the first thing you're going to do is you're going to measure out 50 milliliters of each the 3 molar hydrochloric acid and the 3 molar of the sodium hydroxide. We will be calculating the enthalpy change of the reaction, the neutralization reaction between these two. Remember from our sample problems today, that's sort of a 3-part process. The first part is we need to solve for Q. Q equals MCS delta T, so we need a change in temperature. So when you pour your first solution in, and I'll have you think about whether it matters which solution you put in first, you are going to want to take an initial temperature of that before you start reacting, because that is going to be your number that you're going to use for the change in temperature. So I have an initial temperature here of 20.1 degrees Celsius, and then what I'm going to do is go ahead and put my stir bar in, set it up on my spin station here. I'm going to turn my spin station on, but not too crazy, because I'm going to be sticking a probe in there. And then remember, what we're doing is we are solving for the heat energy that is being released by the system, which is the reaction, and into the surroundings, which is the water. So I want to, as quickly as I can, and it's kind of a 2-part process, or a 2-person process if you can do it, is to pour my other solution in here and get that lid on as quickly as I can. The air from this lab comes from heat being lost to somewhere. Instead of going into the water or into the surroundings that we're measuring, it goes into the surroundings that we're not measuring, like the air temperature. Okay, so I'm going to go ahead and add my other solution in, get my lid on as quickly as I can, and then I'm going to stick my temperature probe in and kind of watch. So at this point, what I want you to be considering is where heat can be lost, where there is holes it could escape from in the cup. Should we be covering those? Should we be worrying about that? And then as well, is the styrofoam cup a perfect closed system? Can the heat be absorbed by the cup itself? If that's true, how would that affect our enthalpy? Would it make it higher or would it make it lower? The other thing to consider as you're watching your temperature is, we know sodium hydroxide is dirty. It absorbs water from the environment, it absorbs other things that makes it impure. We're using sodium hydroxide in here. So if I have a sodium hydroxide solution that's not quite perfect, how would that affect our enthalpy change? So there's a couple things you can do with your Labquest. You can just watch it like this. I know this is really hard to see. You could just watch the temperature like this to see when you reach a max temperature, or in the bottom left-hand corner there's a little play button that you can press, and then a graph will show up and you can kind of watch for the max temperature that way. It actually doesn't matter. You are going to watch it and then record your highest temperature that you get. Once it's done, go ahead and turn your spinner off, take your probe out, remove your magnet with your magnetic stir bar so it does not go down the drain. And since we had equal parts of the same molarity of sodium hydroxide and hydrochloric acid, we just made salt water so it can go down the drain. Okay? So you're doing 3 trials. So that was 1 trial, 2 more trials, and then from there you're going to calculate your enthalpy change. And your 2 analysis questions are, what if the coffee cup absorbed heat? And what if our sodium hydroxide wasn't pure? Something to think about during the lab.